Well, Dr. Johanna Bischof was trained in cell biology and biophysicist, and after a PhD, a postdoc, she joined the Euro-BioImaging with a particular pathway, which is being the scientific project manager of Euro-BioImaging. Johanna engaged with many activities, and I really want to highlight some of them, like, for example, the Euro-BioImaging webinars, where many people join. I have the chance to join some of them, and it's really a great opportunity to catch up with what is going on in the region and what is the ultimate advance in bioimaging, in not only related to microscopy, with biomedical imaging, with all these initiatives. So thank you very much, Johanna. It's a great pleasure to have you here.
Thank you very much, Lionel, for the introduction and for the kind words about our seminar series. That's really great to hear. It's a great pleasure for me to be on this panel and to get to tell you a little bit about my path to being scientific project manager and working at Euro-BioImaging. I started my presentation here with this picture because this is where it all started for me, how I got into science and how I got to ultimately be here. It started with a piece of dirt under a microscope. I was doing a high school course at a local science museum. We were supposed to be isolating DNA and then looking at it under the fluorescent microscope. And as the first lesson in science, so many things, that experiment did not work. We didn't see anything except little fibers from the tissues under the microscope, but they were brightly autofluorescent. And the poor grad student who was trying to keep us 14-year-olds entertained told us that, oh, this is the DNA, you're doing great, you're going to be great scientists. But for me, this was enough. I saw this bright green glowing thing on a black background, and I fell in love. I wanted to do fluorescence microscopy. And that's really how I got into science, how I then started pursuing different research and sort of really continuing always with this focus on microscopy. Yes, there we go. So even before I started my undergrad, based on this fascination with fluorescence microscopy, I got a student job in a yeast lab screening and maintaining the mutant strains, taking pictures like this. Following from that, I started my undergraduate degree in molecular bioengineering at the Technical University in Dresden, which was my local university. I worked on a couple of different projects, first studying wound healing in mice. And then I got the chance to really dig into my fascination with microscopy more, working on developing 3-color fluorescence cross-correlation spectroscopy, so really building microscope and developing new probes for those systems. And I had a lot of fun with really developing the microscopes, but I wanted to do something more applied to research questions, which is then why for my master's degree, I went into regenerative medicine and really did a lot of work on material science. And that exposed me to a number of different microscopy methods. So moving outside of just the fluorescence microscopy, we were looking at cellular interactions with different scaffold materials. So we did a lot of EM, atomic force microscopy, Raman spectroscopy, really got to play around with a lot of really interesting methods that were really important in this work. I also did a second project looking at cellular migration in Drosophila embryos. And that then really led me to going to my PhD position, because I became interested in sort of using microscopy to understand basic cellular processes. And for my PhD, I went to EMBL in Heidelberg and worked in the cell biology and biophysics units, studying starfish oocytes, so looking at cellular mechanics during division processes in these very specific cells. And we did a lot of functional imaging and quantitative image analysis. And through working with starfish, I really got introduced to this world of non-canonical model systems and really enjoyed this, which is why for my postdoc, I wanted to continue developing imaging systems in non-canonical model systems. And this is where I went to the Allen Discovery Center at Tufts University, studying the development and regeneration of the nervous system in planaria flatworms, which are really not a model system that likes to be imaged. So we're really working on trying to develop imaging there. And I think so far, this is a really sort of very traditional career, scientific career path, a very neat story with logical things from one step to the next. But really during my postdoc, something shifted for me, and I kept doing the experiments, writing the papers, but I became really more interested and more passionate about literally anything else that I could do in the lab. So I really took on, all sorts of other roles. I started mentoring a lot of undergrads. We had a very heavy undergrad institution where we could do a lot of teaching. So I got I took as much teaching responsibilities from the other postdocs that didn't want to do teaching. I got all their teaching hours. And that was a great experience. I started doing project management on one of our big DARPA grants, so writing a lot of project reports, organizing project meetings. Just started doing fundraising with our center, working with private donors, which was a very interesting experience, and started doing a lot of outreach with the different projects in the local high schools. And really, at this stage, I probably should have realized that the academic career track wasn't where my passions lay anymore. But inertia is a thing, and expectations are another thing. And therefore, I spent a not very fun year trying to force the faculty track to happen, applying for PI positions, writing grants, interviewing for positions, ultimately all unsuccessful. And that brought me eventually to the final realization that, okay, maybe it's time to really focus on where my passion lies and the things that bring me a joy and satisfaction, not trying to force this career track just because that's what I'd been doing previously. So then I got really lucky, and I wanted to stay close to science, and I wanted to stay connected to microscopy because that had always been my original passion in science. And so I found the position at Euro-BioImaging, and a bit more than 2 years ago, I joined the team at the BioHub of Euro-BioImaging as scientific project manager. And I want to take the rest of the time for this talk just to talk a little bit more about what this position actually involves, because so many of us here are working in these networks, in these building imaging community. And I think it's really important to highlight sort of the different things that we all do in these works. And I know a lot of you are doing this sort of on the side as in addition to your regular job. And I'm very privileged that this is my main job and I get to focus all my energy on this. But I really want to highlight a couple of different things here. Because of course, scientific project management is really diverse. It can look very, very differently. It can be in individual labs, it can be on the university level. But I think in the sort of research infrastructures and networks, it's a very specific thing doing the scientific project management. And I don't think I need to convince anyone here that networks and research infrastructures are really important, but I still want to make this point that, of course, the scientific methods are becoming increasingly complex and interdisciplinary, which means that more expertise is needed to run the instruments and analyze the data, and the instruments themselves are becoming more expensive to get and to maintain. And that means that if we want to have democratic access to these instruments and want all researchers to have a chance to use these advanced methods, we need sharing of access and sharing of expertise. And that fundamentally requires building infrastructures and building networks to provide open access to instruments and to provide sharing of resources and sharing of knowledge. So, and this is when the project management comes in this context. So I was thinking about how to present this. I was thinking about, so what is it that I do in a normal day of my work life? The key part here is really building community and connecting different efforts. And it's sort of a little bit abstract, but that means mostly a lot of talking to people and mainly listening to people, being in a lot of Zoom meetings and hearing all the things that are going on. It means supporting and advising researchers. So we do a lot of consultation with people who are interested in different microscopy things. It means running official processes, project selections, reviews. It means a lot of outreach and organizing events, grant writing, running collaborative projects. And most days it means this: a lot of emails, Zoom calls, and organizing and planning things. In some cases, it also looks like this picture here, or being here, getting to talk to people in person and build these connections in person, which is absolutely crucial. But I really also want to make the point that having started this job and done this job for 2 years during a pandemic, the opportunity to do this remotely is absolutely crucial for the democratizing this access and building these connections on a day-to-day basis. These events like this are fantastic and they're really important to build these connections, but we also need the day-to-day remote contacts. So what I put together a couple of different things that I think are kind of key skills in this kind of work, combining a lot of different aspects from coming from the scientific background, as well as multitasking, communication, people skills, a certain service mindset, and I think a certain degree of idealism and believing in what we're doing, I think is absolutely required here. And I also wanted to talk a little bit about what is actually, I think, the benefits of this job, and what I particularly enjoy and find particularly rewarding in this. On the maybe the idealistic part, it is of course fundamentally a way of supporting scientific advancements without actually having to be in the lab and actually doing the research itself, but really having this impact on the progress of research. It means really working with interesting and passionate people that are really really excited about the work that they do and their job. And it means working internationally and working in community. And I think that's really one of the key things for me, coming from research, where it can often be quite isolating, and then now really working in a team, working in global teams across different countries is incredibly rewarding. I think we've now had this in all of the presentations, that all of these jobs involve continuously learning new things. And of course, that's not different than being a scientist, but it's learning new things in a different way and learning different kinds of things, because you're constantly needing to acquire new skills in different contexts. It also, for me, really means that I get to stay up to the technical development and on the microscopy sense in a much broader field than I would when I was doing my own research. And that's something that's really enjoyable, but getting sort of a quite broad but shallow knowledge on a lot of different topic areas. It means really centrally a diversity of tasks, so really doing a lot of different things. And it means agency over building something and doing the work we do. And agency over outcomes, which is something that's really different than my experience was in the scientific world. So I think with that, I'm at the end, and thank you all for listening.